Right, we're going to be looking at simultaneous equations on graphs. So um, get your learning objectives down, and when you're ready, hit play again. So moving forward. So we can represent simultaneous equations graphically. If we have two linear equations, then they're going to cross at one point. Two straight lines, they're going to intersect at one point. So if we have a look at this example here, draw the graphs of the following equations. 2x plus 3y equals 10 and 3x minus y equals 4. So in order to plot them, the quickest way of plotting them is I need 2 points, 2 coordinates. So what I can do is if I let x equals 0, then I find that y is going to be equal to 10 over 3, and if I let y equals 0, I find that 2x equals 10, so x is going to be equal to 5. So that's a nice quick way for me to find 2 coordinates and plot the curve. So there's your 2x plus 3 equals 10. If x equals 0, y is 10 over 3. That's going to go to 0, so y is 10 over 3. And if y equals 0, then 2x is equal to 10 and x is going to be equal to 5. So I've got my coordinates 0, 10 over 3, and then 5 and 0. And there's my 2x plus 3y equals 10. I can do the same thing with 3x minus y equals 4. At x equals 0, x goes to 0, then y is going to be equal to minus 4. And if y equals 0, then x is going to be equal to 4 over 3. 2 more coordinates, and I can plot 3x minus y equals 4, and there's the point of intersection between them. So we represent them graphically. If I wanted to find the points, I do it as simultaneous equations. Equate the x's or the y and get rid of them. You know how to do that from the last exercise, and we can find that the point of intersection is 2, 2. 2 straight lines intersecting at one point. If I have a quadratic and a linear equation, then they're going to intersect either at one point, 2 points, or not at all. So as an example, if we were to draw this 2x plus y equals 3 straight line linear equation, when x equals 0, y equals 3, and when y equals 0, x is equal to 3 over 2 or 1.5. So I can sketch that. Like so, 2x plus y equals 3. If I was going to sketch a quadratic, I'm sure you remember this from GCSE. Quickest and easiest way is to set out a table. I'm going from minus 3 to 3 here, and I'll put the points in and solve for y for each of these. So by substitution, and that gives me then my y values, and I can plot the curve. And as you can see from the curve, in this instance, the quadratic and the linear will intersect at 2 points. Solving simultaneously will give us each of those points, minus 1, 5, and 2, minus 1. Okay. Now, when you look at this intersection, it reminds me of a formula we've used in class fairly recently, which tells me that in that case we were looking at the x-axis, where a quadratic meets the x-axis. This time we can have a quadratic on a line. Now if we have b squared minus 4ac greater than 0, it means the quadratic and the line intersect at 2 points. So we're going to have 2 solutions. It could look like that with a happy curve and a straight line through it, intersecting at 2 points, there and there. Or I could have a negative or a sad quadratic and it's intersecting at 2 points. So b squared minus 4ac greater than 0 gives us an indication that we got two coordinates. b squared minus 4ac equals 0 means that we've got the linear equation is a tangent to the quadratic, so it just touches it at one point, giving us a pair of solutions. Could look like that, could look like that, something like that. And in the third instance, if I have b squared minus 4ac less than 0, there's no intersection between the two, so there are no solutions. So what I think you need to do now is to make some notes on the discriminant and the description of the three types of intersection, and then we'll have a look at an example. So hit pause when you're ready to have a look at the example, hit play again. So here's our example. The line with the equation y equals 2x plus 1 meets the curve, quadratic, kx squared plus 2y plus k minus 2 equals 0 at exactly one point. It's telling us something about the discriminant there. K is a positive constant. Find k and then find the coordinates of intersection. So if we set it out as a simultaneous equations, the first one is y equals 2x plus 1. Second one, kx squared plus 2y plus k minus 2 is equal to 0. Second equation. In order to solve that, I'm going to get rid of the y because I've got x and y. Can't solve with two variables. Easy to sub the y into this equation here. So I've got kx squared plus 2 times 2x plus 1 plus k minus 2 is equal to 0. If we just write that there, so we said sub for y in equation 2. So if we expand and simplify, kx squared plus 4x plus 2 plus k minus 2 is equal to 0. Those cancel, the 2 and the minus 2 cancel each other out. So I end up with kx squared plus 4x plus k is equal to 0. I now need to find the value of k. Now I know it's got one solution where they intersect. So that means that b squared minus 4ac is going to be equal to 4ac is equal to 0. B is 4, so I've got 4 squared minus 4, a is k, and also c is k. 4k times k is equal to 0. So 16 minus 4k squared is equal to 0, which means that if I take that on the other side, I got 4k squared equals 16. K squared is equal to 16 divided by 4, which is 4, and k is going to be equal to the square root of 4, and it's going to be positive or minus, except it's not positive or minus, it's just going to be positive because we're told that k is positive, so k equals 2. Next I've got to find the coordinates of the points of intersection, so I'm going to change the pen color here. Let's go with blue so I can write it on the side here. To find the points of intersection, I got to solve this equation here for x. Now that's telling me that kx squared plus 4x even, plus k equals 0. I'm going to sub for k equals 2, so that's 2x squared plus 4x plus 2 is equal to 0. There's a lot of 2's. Let's divide by 2. That leaves me with x squared plus 2x plus 1 equals 0. I can factorize that. Put x here and an x here. Plus 1 and plus 1. Therefore x is going to be equal to minus 1. So one of my solutions, well, my solution is there, x equals minus 1. Now y is given by 2x plus 1, which means it's going to be equal to 2 times minus 1 plus 1, which is minus 2 plus 1 equals minus 1. So the solution, the point of intersection, is minus 1, minus 1. So you can hit pause, make some notes, and we'll move on. So some questions for you to be getting on with. I would say attempt as many as you can. Question 8 looks like a very interesting question, so I'm going to make sure you do that one. But I'd start slowly first, sketching the linear curves, the linear graphs. And number 2, sketching the quadratic and linear. Make sure you do question 8. Make sure you do question 7, A, B and C. Okay, good luck.